Hi, this is Ken from Smart House Electric. This is a introduction and a quick run through on how to read the Ergoline affinity diagram, which is an electronic 2 series. That means that you can use the same way, and it will be pretty much the exact same build up for an Evolution, Excellence, Soltron, Wave, Chill, Shark. So all these are named electronic 2 tanning beds, and they will have this kind of system where you're using a matrix. You see the numbering up here. It's kind of hard to see. I will really urge you to print out this whole diagram and run through it, and then you have it for troubleshooting later. But up here you have divides, and these are indicating columns. Let's go down to the first page so you can better see how it relates there. So you have column 1. That means that everything beneath that section there belongs to that column, and so forth. 2, 3, 4, 5, 6, 7, 8, 9. So when you have something, let's say that it's located here in 7, that's how from another page that it will relate to something coming from here. So let's move a little closer here. Oh, hopefully you can see it. So there's a number out here from the wire where it ends, and it goes into another diagram that you have to go out and find in this. And it says here the first number 3, and that relates to the page. First number is the page. So on page 3 you will have the continuance of this wire, and it says it's going to be in column number 1. So now we know that we're looking for L1GB. It says SW for German, it's Schwarz, that means black. So there's a black wire named L1GB, and it's in column number 1 on page 3. Let's test that out. So alright, so we're here on page number 3, and well, I knew this one here, didn't want to waste your time, so so you will see the opposite down here. Here, of course, it will relate to, it will say, okay, coming from page number 2, which we were before, and then it said in column number 7, and so we have the L1GB black wire, boom. So that's the system of this. This is that matrix system, how this whole diagram is built up. Now let's get back to the first page. So looking out here on the right hand, you see it says control lead and filter. That is main power. Let's look quickly down on that. And here you have the main lug down here. That is the power coming in where when you open the trunk in the bottom of the tanning bed. On the far left you have the big styrofoam box with all the electronics in. Behind that you have the main power. You see all the big wires coming in. You have a lug there, like a big connecting point. That's what you see here, and you can identify that. This is L123 and N123, and P, that's your ground. So you can see those over there. This one is wired for 3-phase because it has the lugs connected, L1 to N3 and so forth. So that's the way to see that it's wired for 3-phase for an American power. Now, had it been Europe or to any other 230 volt application, you will just have the 3 phases going through, and you will have a neutral wire going through all these ends here and have them latched together. Lastly, I want to say for Americans, single phase would be all the L's connected with latches and all the N's connected to one another with latches. So all the L's are connected, all the N's are connected, and then you will have one phase going in on the L's and one phase going in on the N's. So if you receive a tanning bed from the United States to another country where you have 230 volts, you'll know what to do. So by looking at this diagram, let's quickly just run through this. So you have all the control voltage of the tanning bed out on this side here, off to the core light, that sort of thing, stuff that needs to not be dependent on the lamp contactors that you have here. And so what you see up here is the low voltage transformer that's going to supply all of your electronic boards inside. Is a 24 volt sorry, darn foreigner, a 24 volt AC transformer that then goes into your what's called a slot PCB, which is the PCB down in the bottom where everything plugs into, and that's going to convert it to 30 volt DC down there on a rectifier, and then also have a 5 volt production going on down there. So, but we're going to get into that later. And here are some lamp breakers. What you see here, interference filters. That's the you have 2 leads coming in and you have 4 coming out. You can see the plugs there. It's pretty much in the middle of the styrofoam box as you look down. These are notorious for arcing out and melting. So if you have parts of the lamps out, look there. You can pretty much always smell it, but you might be coming to, as a tech, to the place days after that this has happened, and sometimes the awareness in the salon can be maybe not so much on the technical side, but look in there if you have parts of the power missing. And also if one of the breakers have tripped, take a look at that, you know, and see if one of these look melted or arced out. Okay, so that's all your power coming in. So between the plate there on the back and the styrofoam box, then you can move on to all the subsystems. And so you can see here it's listed with pages: ballast, facial tanner, canopy, facial tanner. So this is down in the ballast tray, and then that's going to lead to the next page of the diagram, which is the actual facial tanner lamps. So let's quickly jump down to those, just to quickly run through that. So you have the ballast system, and also in the back of this, let's just jump to that. I want to say it's at 22. Let's see here. There we go. There we go. So you see there's all these are named like VSG something, blah 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 blah. That number would be in the diagram, so you can find these in your ballast tray because it's all numbered. And the same thing goes for these capacitor, all your power factor equalizers. That's why you have them, because all this choke ballast stuff here creates a massive inductive force that creates something called a power factor, and so we need capacitors to equal all that stuff out. I'll make a whole video on that just by itself about power factor. Very, very important topic. Alright, back to facial tanner. Ballast. Ballasts is what you can see here, and they're located down in that ballast tray in the middle where the rod that holds that your base up. Well, you can see all the ballast down there. And so these are cascaded together, as you can see, parallel, so that you can connect and create facial steps. Like you start up on all 4, and then you're able to decrease the power by taking away these ballasts. See here how they're connected through these contactors here, K4, K5. Same thing over K4, K5, K4, K5. So that is that, so that when you disengage K5, you will step down by, let's get a little closer here, then you will step down by 160 watts. And if you take away K4, you will go even 100 watts further down. So that's how that is all connected. And then, as we remember, so it says 4.1. Look at that up here. It's kind of really small. That's also why you really got to print out this diagram so you can kind of follow along like that. This is going to be pretty blurry, I think, to look at. So, but 4.1, that means that you go to the next diagram to follow it further. And see, that's where you have it. You have it here, coming in, boom. So you find your wire there from 4.1 from the last one, and that goes from there. So that's how, that whole matrix system that we talked about earlier in this video, how that's that's how you transfer from one page to another and still can find that wire. And so very classical setup here. You have the igniter here, so you have power from the ballast coming in, boom, on D, and L is your actual igniter leg, the one that fires the lamp up. And then you have your back feed here, which is the other phase. So you got an example, and just an example. You just need opposing phases. So you'll have L1, for example, on this side. You'll have L2 or L3 on this side, creating a voltage difference across the lamp with a ballast ahead as a big current break, and it will make that initial spark together with the igniter. Now, be aware of this, is that the igniter doesn't know if there's a lamp in there or if the lamp has blown out. It can just feel that, hey, the lamp didn't start, so I'm gonna keep on starting. So knowing that if you have a lamp out on this igniter is gonna keep on igniting over and over and over again. So it's a very hard life for a lamp to be out for the igniter, actually. Or if you take the lamp out, you're thinking like, okay, I'm just gonna disconnect it, no problem, and just leave it there. The igniter actually keeps on hammering away on getting the stuff to work. So let's jump back to our overview here. And so that was our facial tanner section here. Canopy lamps, boom. Here we go. So that's our low pressure lamps, also very standard lamp setup that Ergoline has used here, where you have power coming in on one side, running through the cathode here. This is the actual lamp you see here, and so the cathode on the opposite side here is connected with a starter. I have a whole video on that. You need to, how a choke ballast work, go in there and look at that, and you'll if you haven't heard of how this lamp business is started up. But here's where you find the lamps, and again, see how they have, see here, okay, it's very cool to see that you see the ballast that's connected to the lamp. It says VSG 1, 2, 3, 4, 5, 6, blah, 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 blah. Remember back here on, what was that page? Was that page 21? Yep. That's where you, so now you can identify all of these, very easily. Alright, and our lamps lamp location starting from LA1, and let's jump back to the lamps here, and then you can see LA1, that was the location of this lamp, and then the ballast VSG1 is down here electrically, and then physically you can find that picture in the back of the diagram here, or of our little diagram collection. So let's jump back to the front page. And so that's how we have all the lamps showed. Let's go to 9. That's our control voltage. All of our electronics, the basic build-up of those. Probably have to make it a little smaller. Alright. Okay. So all this is showing the I2C bus. The I2C bus is all the orange wiring, and that is the communication between your display, your AC control, which is that if you have an AC in there, you see like a black box standing in front of it. Inside of there, there's an electronic board, and that is controlling that whole mess, you know, the heater and the AC. And so that needs to communicate also with this I2C bus, which is, you know, like a digital communication that is made by Philips once upon a time, and used by very in many designs, electronic designs, not just tanning. This is really something very standard. So besides the I2C bus, though, see, an I2C bus is typically just 3 wires. Here we have actually 5. That's because we're running our supply voltage out to all these functions, which is a 5 and 30 volt DC. So that's running in here as well. We can actually see that here. Yep. So there you can see it. Yeah. LDA is actually a communication coming out on pin number 4 here, next to the ground, and LCL. A lot of people believe in tanning that this one is actually return data, and it's not. It's not a transmit and receive. Everything happens on 4, but you still very much need the LCL signal. But that's actually the clock pulse. That is what is setting the pace of the data, so that the right data gets into the right slot, if you will. So, but for those that knows computers, that is your clock pulse there on the middle leg, and next to it is the actual data. And then out from the opposite side of the ground wire, you see here you have the 5 volt and 24 volt. So, so that's what's connecting out to this, what's called the I2C bus. And that's what you find in here. You can see what pin numbers everything is on. What I want to additionally say to the I2C bus, we're getting into that later actually, I'm sorry. But a lot of other stuff is, well, Aroma and Aqua. If you have that, or your music system, everything there is somehow connected to the control system will be hooked up to this I2C bus. So let's move it along. Let's jump back to our, oh, sorry. And I/O. We might as well just keep on hammering down now. So, okay. So here on the main board, you have a bunch of outputs here. And these are all gray wires pretty much. What they are all doing, from there is supplying 230 volt out from. There's a bank of relays on the main board, but they of course can't like pull lamps, so it's outsourced to the real contactors. So there are those you will find here as a diagram. You can see where they're supplied from, so you can see if there's a function that's supposed to be on, you can see if there's 230 volts coming to the contactor, and if there is, there's probably something wrong with the contactor if it's not engaging. Or you can actually check voltage difference between the point A and the point on the main board, and you can see if there's a wire that's gone out or something like that. Just so you know, this is that area, and you can. Here is the functions of each contactor, so you can see what the pins are doing on that actual contactor, and they made it nice and illustrated and showing here, as you can see, what these contactors are for. So a lot of help there. Let's move, oops, to this guy here. That's the safety chain. So the safety chain is all your little switches. When you open up the trunk, you know how the light turns off, you can turn on the bed, and it turns off the timer, so it beeps up front at the T-Max timer. This is where that whole circuit is tied in. Also fuses for temperature fuses, any kind of safety you find on this page here, on page 11, and pretty straightforward there. Let's go further, and that of course goes back to, well, not of course, but it goes back to your main board as an input, and that's how the bed can determine whatever code it has. And so 12, that's warm air recovery. Okay, so that is so that you can you can lead the hot air from the tanning bed into the room if you have a very special plenum that's able to relocate air from one side to another. You can not such a huge not something you're really using in the here in the States. So okay, page 13, fans. Real quickly about fans, they are controlled by these two fan boards typically. Some of the smaller units, there's only one. One fan board controls two fans, and it's controlled through the bus system, so you know that's how they're plugged in there. Something I want to say here, we have a whole video on the electronics of this all this electronic too here, but just quickly want to say that you have to get these boards into the right slot. The two fan boards though, you can swap those around, they're interchangeable, but they have to go in the right slot for fans. So if you take them out, really pay attention to where you took them from. So here you see how the fan boards are simply supplying the fan straight on. So you will find also fuses on the fan board, 6.3 amp fuses that sometimes would go, and you can replace that and you're good to go. Most of the time, even though they're gone, the fan is still dead. And so I urge you to look at the video about capacitors, because that one shows really well how these fans are operating, and it's a very common problem to have a problem with these capacitors that you but they're very smart, because this makes it even possible to run this bed single phase, and also the rotation of these fans, the order, it just makes it very easy that we're using that kind of system and not just using all the three phases to run these motors. So that's what you find here. And so this little guy here, this is cooling for the facial tanners. So that is a 12-volt system. So by each facial tanner, you have a tiny fan in back of it. So if you have heating issues on a facial, it could be this little fan that's gone out. And so that's where you find that is on this diagram here. And okay, so this one here is also interesting. Page 15. That is your coin box PCB. So that means that how it's tied together with your T-Max timer, because this is important. As an American customer, these T-Max timers that you see inside, this brick timer and whatever, the machine is not born with it. It is something that is built after, and so you actually have the option to build on any kind of starting system for these Ergolines. Huge possibilities for doing some kind of other control system, and it can use both 230 volt in, and it has an option for 24 volt in. So lots of options, and you can see the diagram here, how you have different ways of connecting this. So alright, and that's the coin box PCB. There's also located, this is one of the electronic boards that you have in the styrofoam box. Again, I refer to the electronic 2 video we have on that. So decor light on 16. One heads up here would be, if you have a tanning bed that has an issue that right after cooling, that it trips the breaker, you most likely have a problem in your decor light, because that's when they start up. Let's see here. Oh yeah, 17. That's your shoulder tanner. Here you have the ballast and everything located out in the ballast, in the shoulder tanner. So the entire circuit from the plug on is to be found out there, because this is something that's not, this is an add-on to the machine. Okay, so 18, that's the aroma and aqua. Again, this is a separate board. It is an add-on, so it's on the I2C bus as well. That means that it has the orange wiring, so you see down here, device, bus. So, and then everything here is 230 volts. These little pumps and all this for the water is actually 230 volts. Yeah. 19, page 19. So that's your audio, and actually also a lot of options here. I mean, you have channels. There's a whole guide for sound actually. So if you're hooking up sound, don't use the diagram. Download the audio guide, JK's audio guide, and use that. That's way better explained in there. But this is the section, of course, of the diagram showing all of your audio hopefully it gave you some idea about the electronic 2 build-up of this diagram. And again, it's a very common build-up, this matrix system where it relates to another page. Really smart because you can just use regular paper. You don't have to get a big ass diagram. So thank you so much for watching, and hopefully you're interested in more of the videos here on the channel. Please comment below. Also, if you want to see something else, something you're interested in, something you want me to show and tell. Granted that I can, but I'll definitely give it a shot. And thank you again. Take care. Until next time.